So, week two, we are on week two right now. Please have a look at what's ahead of us this week. Today is the due date for your lab report on potential and kinetic energy and also the quizzes. The quizzes expires at 11:45 tonight. So please make sure that we turn that in. The discussion question today is quite short and easy. So you can finish that. Don't wait until Wednesday because it's very short. It's just a matter of choosing A, B, C, or D after you've watched a video about conservation of energy. All right, so that's it. Tuesday, Station Lab will be available. Now, common mistakes from most of you, not most of you, but probably a few. Don't forget to hit submit at the end of your Google form. We know that when we are doing our test, it's not going to automatically save. So please make sure that you hit submit towards the end. I put reminders every part of your lab so that you will remember how and when to turn in and submit. You have few days to work on those study guide station labs. Part of it, watch it, read it, so you can break it up because we are not going to have too many assignments this week. So I want you to spend more time on that station lab. And that's not due until Monday next week. Wednesday, continue with your lab. Discussion post is due on Wednesday. Thursday, I will be posting a short reading, what it's like to live without electricity. And on Friday, of course, just your quizzes about it's actually more of a flip grid about science at home. So I will be posting that on Friday. All you need to do is to respond to a flip grid, and that's going to be what our week is going to look like this week. All right? Okay, so let us get going. Okay? If you don't have any question, I will move forward. But if you do have any question, just put it up on our chat so I can address them. Otherwise, we're going to move forward. Okay, so just to give you an idea of how the week went last week and what are those, not a grade category, but a category of what I post in the class. Of course, we have our discussion questions. It's always posted on Monday, Padlet or Flipgrid, whatever form or format that is. It's once per week. Station Lab is always one a week. Ed Puzzle, one or two, or a study guide. So either or, Ed Puzzle or study guide. So we have study guide, so there's no Ed Puzzle this week. And of course, your quizzes quizzes, okay? I think it's much better. You get your feedback right away if we do quizzes, and that's going to be one per week. And then your readings, this week we have a reading. Last week we don't have a reading, so it's every other week. And then when we get to waves, after we discuss about waves, there will be one full week that we're going to do a project or research. I just wanted to give you guys a heads up on that. I'll also put this in your Google Classroom. All right, so just to give you that idea. Okay, also, even though we are not in the classroom, Mr. Agasani shared this with us, with your teachers in terms of instructions. All right, so any talking during instruction, which I don't think we will have a problem with that. That's going to be something that we still use Kickboard for, or maybe parent email on that. So just hold off on, being out of control on that. Level 2, disrespect, dishonesty, and stuff like that, either in a chat room or off, like let's say, for example, Google Classroom, when you type in the comment, just be mindful whenever you send a message or something like that. On your videos, I don't think most of you guys are not on video right now because All right, so you don't need to turn your video on right now because there's no need. Probably in the breakout session, if you want to see each other, you can, but still always be mindful on that. All right, so the level 3, it kind of like translates just like how we are in school, but obviously we know that any disruptions in the Zoom meeting is a level 3, giving Zoom password to someone outside. That's a level 3. And then, of course, our admin, Mr. Egasani, will be dealing with the level 3 types of infraction. And I'm confident that you guys know how to act accordingly in all these, because school policy still applies even if we're working online. Okay, so if you guys want more of information on that, I will ask if we can have that posted on the global classroom, just so you guys are aware of our policy still for discipline. All right, so our learning objectives today is we are going to describe and identify the different transformation of energy. And then, of course, we are going to identify how each scenario shows energy transformation. And lastly, you guys will be working with your other classmates to identify the energy transformations happening in examples given to you and your group mates. And that's also found in your study guide. You can work on it later on. All right, so we will get going and explain to you guys the topic. This will also help you when you do your station labs tomorrow. Okay? All right, so you are able to address everything in your lab if you know how to demonstrate energy transformation in different scenarios. So that's our goal today. All right, so energy transformation has to do with the process of changing energy from one form to another. Later on, if you want to look back on this, any highlighted words are the words that we will be putting on your study guide later on. All right, so you may do it right now, you may do it later. I think I would rather have you do it later on, but I'm going to go through it. All right, and another thing about energy transformation, it has to do with the flow from one type of energy to another. And while we are out of school, the 2 weeks before spring break, we have that background of this, so I'm not going to spend too much time on this one. All right, so let's move forward. Now, conservation of energy, which is also going to be discussed in your discussion post today. According to the law of conservation of energy, energy can neither be destroyed nor created. I asked this last week for you guys to explain. It doesn't necessarily mean that energy doesn't really disappear. Energy just transforms or changes from one form to another. So an example is electric energy converts to heat on a stove. So if your stove is an electric stove, then of course from electricity, it converts into heat. So energy in, energy out. So that is the basic explanation of what conservation of energy is. Okay, and we have the two types of energy we discussed last week. Energy stored is potential, and energy, moving energy is kinetic. So there are different forms of potential energy. You have your mechanical, chemical, nuclear, and electrical. So in your study guide, the highlighted portion of this would be the one you'll plug it in. Our study guide, by the way, today is a Google slide, and you just have to fill out, okay? So just so you guys know, when you look back onto this presentation, that's what those highlight features mean, okay? All right, next up, kinetic energy, like I mentioned, is your moving energy. And there are different forms of kinetic, and we're going to discuss that in detail today. So we have mechanical, radiant, electrical, thermal energy, and sound energy. So we're going to go through that today, and we're going to show how each of these forms of energy change from one to another. Okay, so just to summarize what I showed you in a more visual terms, potential can be chemical. So if you notice, that's an example. The rocket fuel converts chemical to a different form of energy. Mechanical, your gravity, electrical, nuclear, and mechanical elastic energy. So these are different forms of potential. Now, once it starts moving, electrical, sound, thermal, mechanical, and you have your radiant energy or light energy. You also call that light energy. Okay, so we'll start first with mechanical energy. And the energy a body possesses because of its motion is caused by gravity or elasticity. So an example would be a flowing water, winds, arrow shot from a bow, and bouncing on a trampoline. So these are some examples of mechanical energy that is kinetic. Now, mechanical energy that is potential is energy a body possesses because of its position. So it's not moving. Energy is stored by gravity or elastic potential. Now, an example is book on a table. We have a lot of examples right now. If you're just sitting there not doing anything, that's another. Compressed spring is another potential. Rubber band pulled back is potential energy. So just to give you an idea, I've read some of you guys' lab. There's one that's asking you potential or kinetic energy. When you stretch it, it is a potential energy. Okay? All right. Now let's answer this time. So you can just answer this in the chat box and to participate. All right. So where is the mechanical energy here in our example? You can type it down on your chat box and answer. What is the mechanical energy here in this diagram? Anyone? Yes, Jace is a windmill. Let's take a look if that's our answer, okay? First up, it's the wind, okay? So the wind, if you're not sure, take a look. So the wind, how about the mechanical, another mechanical energy aside from the wind, we have the blades or the windmill itself, okay? And then of course, another mechanical energy is of course the pump. That is the flow of energy. So from the wind to the turning of the blades and then the pump. So all of these are mechanical energy. Now let's take a look at your thermal energy. Now thermal energy is the same as heat energy. You can call that heat energy as well. Now the total energy of atoms and molecules that are constantly in motion is thermal energy. And some examples is a burner of a stove top turned on is thermal energy. Hot cup of cocoa is another example, and of course your fire. Okay? So let's take a look at the flow of energy, this time in the candle. Okay, so let's start with that. So first, there is chemical energy here, and where is that chemical energy? You can just type it down. What is our chemical energy here? Anyone? The candle itself, yes, the candle wax, correct? That's our first one. That's our fuel. That's why it's chemical. How about thermal energy? What is the thermal energy here? Connor says fire. Let's take a look. Or the burning wick or fire, the flame, yes. And of course, radiant energy. Where is that radiant energy coming from? It is the light being emitted. Correct, Bryce. All right. So that's it. So I hope you see the pattern, because you guys will do the same on when you guys answer on your assignment for the guide today. Okay, let's now go to radiant energy. So radiant energy is also referred to as solar or light energy. Now, this energy is caused by the movement of what you call electromagnetic waves. Now, electromagnetic waves, we're going to talk about that when we go to waves next week. But we'll focus on how this is converted from one form to another. Okay, so example would be your light emitted by light bulbs. So at home, the light actually emits radiant energy. We know that. The sun emits radiant energy. And of course, your microwaves emit radiant energy. So that's another one. Okay, let's take a look at the flow of energy this time in this illustration. So first off, radiant energy is coming from the sun, obviously. How about the chemical potential energy in here? What is our potential energy? Chemical potential, specifically. So sun is your radiant. Where is the chemical? Jace, he said grass. Anyone else? Grass, correct. Mimi, Edgar, it's the grass or your photosynthesis. Photosynthesis is the process that, of course, will produce that grass. And lastly, another chemical potential, of course, the food that your deer is eating. So that is another chemical potential energy. Okay? All right. Let's move on to sound energy this time. So energy in the form of wave motion. So that's another wave discussion, which we'll discuss next week. That is sound energy. Now, it is caused by vibration. So the vibrations spread in all directions as one vibrating object touches one another, causing it to vibrate. And an example is your drum. We know any instrument, if you're playing band, then those produce sound energy. Talking as well produce sound energy. Okay, so let's take a look at how sound energy transforms from one form to another. So we'll start first with the solar energy, solar potential energy, and electrical energy that is potential, and electrical that is kinetic. So we'll start first with the solar energy. So of course the solar energy, potential energy, where is that? From the sun. That's correct, Connor. And then electrical energy that is potential. Where is that at? We see that on the solar panel. That's correct, Edgar. And how about the electrical energy that is kinetic this time? Where is that kinetic energy this time? From the wires, not the telephone lines, but the electrical wires. And lastly, the sound energy that is kinetic is, where is it at? Either your phone, that's correct, the speaker on your phone, or your radio, which produce music. Okay? So that is the transformation going on in here. Electrical energy. Let's move on to the electrical energy. So electrical energy has to do with moving electrons from one point to another in a conductor. So an example will be the electrical current in the wires, which we previously saw. Lightning is another example of electrical energy that is kinetic. Now let's take a look at what about if the electrical energy is potential, meaning it's not used or it is stored. So it is stored electrons that's not moving. An example would be your light bulb that is turned off. That is electrical potential energy. Another is your stove turned off is another electrical potential energy. And of course, if there's power outages, of course, the energy is not being used and therefore it is potential energy. And of course, the electrons in the cloud is another electrical potential energy. All right, so let's take a look at the flow of energy here. So I'm just going to go through it real quick because we already know the rhythm. So we'll start first with electric energy that is kinetic. Of course, that's your lightning. Thermal kinetic energy, of course, the fire. And that's pretty much it. There's two flow of energy in this example. Now let's take a look at chemical energy. So there are different examples, a lot of examples for chemical energy, but this is energy stored in chemical substances. So that's your chemical PE, okay? Fuel is an example of chemical potential energy, as well as explosives. Food that we eat is another chemical potential energy, and batteries that are not used is chemical potential energy. Okay? Wood, if it's not been burned yet, then it is chemical potential energy. Let's take a look at the energy flow this time in here. So, chemical potential energy, of course, is your battery. Electrical energy is that's kinetic, is the electricity that flows through the wire. And radiant energy, when the light bulb lights up, then that is your radiant energy. Okay, lastly is your nuclear energy. And of course, if nuclear potential energy is not being used, then it won't be converted to a different form. But nuclear energy is also called atomic energy. And the energy is found in the nucleus of an atom, and it's stored in there. And what happens is it can be released by the process we call fusion. It means that you're combining two atoms' nuclei or nucleus, or splitting the nucleus of an atom. And it takes a lot of energy in order for this energy to be released as a great amount of energy. So it takes a lot of energy to either fuse or combine the atoms' nuclei together or split them apart. Example of that is, of course, your nuclear power plant. It uses nuclear fission. We split the atoms to produce lots of energy to convert later on into kinetic energy. The sun is another example of nuclear energy, wherein you combine nuclei of atoms, so that is fusion reaction. Okay, so here is an example of your nuclear energy. So let's take a look at and trace the energy flow. Of course, it starts with the nuclear energy potential from your nuclear power plant, where labeled A right here. So we have the nuclear reactor in here. That is your nuclear energy, that's potential. As soon as, of course, it starts working, our nuclear power plant starts working, it converts to mechanical energy, that is kinetic. That's wherein the turbine starts moving. And lastly, when the turbine starts moving, it generates electricity when it goes to your generator. So we are in letter B. And then letter C is, of course, our electrical kinetic energy, sending that electricity to the city. Okay? So that's A, B, and C. So this is the flow of our nuclear energy. This is what you guys will answer in your study guide, just to give you an idea before I start. So you're going to identify and describe the energy transformation happening in each image. So there's 1, 2, 3, 4, 5, 6. So you guys are just going to answer together with your group. So again, have your study guide ready on this page right here. Hi guys, this is Mrs. White. Just want to make sure that we are on the same page. Today is the deadline for Potential and Kinetic Energy Lab, as well as your quizzes for PE and KE quiz, potential and kinetic energy quizzes. This week though, here's what's coming up. Today I just posted your study guide. Please use the slide or this recording to complete it, including the discussion post, that's energy transformation, conservation of energy, posted today. Just answer it, A, B, C, or D. Tuesday, It's going to be station labs for energy transformation until Wednesday. So that's what you're going to be working on for 2 days. Please, please, please hit submit every single time. If you stop working on the station lab for energy transformation and you are going to continue the next day, please hit submit. Thursday is going to be a reading, what it's like without electricity. And then Friday, we have a flip grid. So there's no quizzes this week, just all those things that I've mentioned. All right, so if you can make it next week for our Sci Live next week, I will see you then. Bye.